Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe the channel, and if you like this lecture, please hit the like button. Now let's proceed with the projections of plane surfaces when they are making angle with one plane. Let's take a pentagonal lamina of 40 mm edges, has one of its edges parallel to HP, or it can be even given as perpendicular to VP. Let's see how it is. It's a surface making some angle with the HP. This is the problem. Because its surface is making some angle with the HP, we take the plane first parallel to HP. Okay? Because it has one edge parallel, no, then parallel is enough. Okay, it's not resting. If it is resting, then you have to take on the HP itself. So here we'll take the plane parallel to HP like this at some height above HP, and its surface is making, its surface appears like a straight line in the front view, and now it is making some angle 30 degrees with the horizontal plane. So draw this line, take the plane here at 30 degrees angle and draw the top view. This is the final position. Now let's draw this. Let's see how to draw. So first of all, we draw the pentagon in the top view, having one of its edge perpendicular to VP. So here when you take the edge perpendicular to VP, and if you tilt it afterwards, this edge will be parallel to the horizontal plane. We'll see how. So draw the pentagon such that one edge is perpendicular to the reference line. Show the dimensioning, mark these corner points, all the points here, and draw projectors from all the points and draw the front view. In the front view, take the extreme points here, extreme projectors, and draw the line parallel to the reference line. Corresponding to all these points, mark the front view points. They are A dash, B dash, like this, all the points in the front view. Now, in the front view, it is appearing like a straight line, the surface. It is making some certain angle with the horizontal plane. So draw a line here at a 30 degrees angle to the horizontal plane, right? And I want to tilt the plane like this, upwards. We can tilt anyway, either this side like this, or even you can move it upwards like this. Because we want this AE is, this point in the front view is an edge actually. When you tilt it upwards, this AE edge is perpendicular to the VP or parallel to HP. Okay, this is the edge that is parallel to HP also. Now, I want to tilt this like this. That means AE is kept in the same position and lifting point C upwards like this. So draw a line here at a 30 degrees angle, right? And the same front view length is marked here without any change, no change at all. So the front view is drawn here. Now mark these same points and here on the front view. So A dash, B dash, C dash, like this, we have marked all the points. Coming to these points in the front view, we have marked this D and E within brackets, because when you look at it in the front view in this direction, this ABC are nearer to the observer and D and E are away from the observer. So D and E are kept in brackets. Now, from all these points, draw projectors here like this. Draw projectors, and coming to the top view, the points, we are not moving the plane away from the vertical plane. The plane is kept at the same position. So all the points are at the same distance in front of VP. So A is at this distance, B at this distance, C at the same distance, like this. So now draw horizontal lines from all these points. Now A dash is here and A is here. From this, we have drawn a horizontal line. From A dash, a projector. These two will intersect here at a point called A, because this is the top view. This point, intersection point, is called A. Similarly, B dash, B, intersection point is B. Like this, we get all the 5 points here. Join them by straight lines. You get the final figure like this. So this is the final projection in the front view, final projection in the top view. Okay. Now, let's take another example. A pentagonal lamina of 40 mm edges has one of its edges parallel to VP. Here again, parallel to the vertical plane. And surface making 30 degrees angle with VP. The surface is making angle with VP means we have to take the plane parallel to VP or in the VP. Because the plane, none of the plane edges or corners are resting in VP, we can take it at some distance in front of VP. So the front view appears like this. So in the first position, the plane is taken like this, okay, parallel to the VP at some distance in front of it. So in the front view, we see the true length and the true shape of the polygon. That is the pentagon. Now, in the top view, it appears like it is a surface of a negligible thickness. So in the top view, we see it as a line. Take this line at 30 degrees angle to the vertical plane. That is visible in the top view. So draw a line here at a 30 degrees angle and show the line at 30 degrees. From this, we draw the front view. So these are the final projections of the pentagonal lamina when you take the actual surface. But we are going to draw this using only the edges, right? Let us see how to draw it. Take the reference line. Now, draw the pentagon in the front view first. How? Perpendicular to HP. You take one of its edge perpendicular to the horizontal plane like this, perpendicular to the reference line. You take one edge here, right? And this edge automatically will be actually parallel to VP also. We'll see it later. Now, mark the dimensioning and also the points here on the surface here, A, B, C, D, E. Draw projectors from all the points, okay? And the surface is taken somewhat in front of it, parallel to VP. So at some distance, convenient distance, there is no rule that you have to take this much. So take some convenient distance and draw the top view here. In the top view, it appears like a line. Now, corresponding to all these points, you mark the top view. So A, B, C, D, E like this. Coming to this, when you are looking from the top in this direction, B, C, D are nearer to the observer and A and E are away from the observer. So A and E are kept in brackets. Now, this surface, which is appearing like a line in the top view, will be taken at 30 degrees angle to the VP or the reference line in the top view. So draw a line here at 30 degrees angle. On this, you mark the same length here, BD. This length is marked here and mark all the other points also. Exactly, it's the same. This line is at 30 degrees angle, given angle 30. Now, draw projectors from all the points here from the top view to get the front view. In the front view, when you see this first position, we are not changing the height of this plane above the horizontal plane. The pentagonal plane is at the same height, just only we are moving this point D away from the VP. So all these points are at the same height above the horizontal plane. So that's why you draw horizontal lines from all these points, from A, B, C, D like this. You get this. Now, corresponding to this top view, because A dash lies on this projector and point A is at this height. So this intersection point gives you A dash. Similarly, B dash, C dash like this. Get all the points. Now, join all the points by straight lines. Here, this is. So if you observe the final projection, this point A dash, B dash is vertical, right? Vertical. That is perpendicular to horizontal plane. This is what is required. Or when it is perpendicular to VP, and if you see it as a point in the top view, that means it is parallel to the vertical plane. So this AB is parallel to VP, that is condition is satisfied. Automatically it will be satisfying this condition also, perpendicular to HP. Okay, so these are the final projections of the pentagonal lamina. Let's take a hexagonal lamina of 30 mm edges resting on one of its edges AF in the horizontal plane. Edge name also is given. So we have to show that edge in the horizontal plane. It's a surface making 30 degrees angle with HP. So let's take the plane like this. Because we want something in the horizontal plane, the plane is taken in the horizontal plane itself. Now, its surface is making an angle with the HP. That's why we have actually taken the plane in the horizontal plane. Okay. Now, let's coming to one more thing, resting on one of its edges. Because we want an edge in the perpendicular to the reference line, take this one edge perpendicular to the reference line while drawing the top view. That means when you are tilting upwards, this edge, this is the edge here. This edge will be, this edge will be in the horizontal plane. Okay. So to satisfy that condition, to have one edge in the horizontal plane, tilt the surface like this. Okay. Now, so this is the top final projections. Let's draw the actual drawing. So coming to this, take one edge perpendicular to the reference line, draw the hexagon in the top view. Okay, this edge I have taken AF perpendicular to the VP and drawn the hexagon, marked all the points. Now draw the projectors and mark the front view here. From here to here, the front view is marked and the points are marked here. Its front views A dash B dash like this, because A, B, C are nearer to the observer. Observer is looking from this side. So A, B, C are nearer to the observer. D, E, F are away from the observer. So D, E, F are kept in brackets. Now, its surface is making 30 degrees angle with HP. I will lift this upwards like this. Okay, because here it is mentioned AF edge is in the horizontal plane. We must keep this AF on the horizontal plane itself. So that's why we will lift this point CD, this side upwards like this. When you lift this CD upwards and show the 30 degrees angle here, this is it. So we have drawn a line at 30 degrees angle and marked the same length of the line here in the front view. Mark the same points also. Absolutely, there is no change. Now, draw the projectors from all these points and draw horizontal lines. Already we have seen that we are not disturbing the position of the plane. So, from all these points, we have to draw the horizontal lines here like this. So, get the intersection points here A dash, here A. So the intersection point is A. Because this is the top view, all the top view points, that is A, B, C, D, E, F are marked. After marking these intersection points like this, join them by straight lines like this. You get the final projection in the top view. This is the final projection in the front view. So like this, we'll be drawing the projections of a plane surface. Next, let's take a hexagonal lamina again. It's resting on one of its corners in HP. Now it has a corner in HP. And the surface is making 30 degrees angle with HP. So here, two things are to be taken care of. One is, it's a surface making 30 degrees angle with HP. So first take the plane either in HP or parallel to HP because of the surface inclination. Second, it is resting on something on the horizontal plane. That's why take the plane, entire plane in the horizontal plane itself, like this. So we take the plane on the horizontal plane parallel to the, that is in the horizontal plane means automatically you can even call it as parallel to HP. Now, we have taken the corner on one side, either left side or right side, you have the corner. So we can have the corner in the horizontal plane. Now, this is the position. When it is making, surface is making 30 degrees angle with the HP, you get the plane like this. Let's draw its projections here in the drawing. Take the horizontal reference line, show the top view such that you get a corner in the left side or right side. Of course, here we got on both sides, we have the corner. There is no problem then. So show the dimensioning. Next, draw projectors from all the points and show the front view here. So F, A, B, C are nearer to the observer. They are drawn normally. D and E are away from the observer from this side. So D and E are kept within brackets. And now let's show the surface inclination. It's making 30 degrees angle with the HP. So the same length of the front view, the same is taken. Same length. Nothing, no, there is no change at all. This line is taken at a 30 degrees angle and mark the same points here. Absolutely, there is no change. That means we are getting a corner F in the horizontal plane here. We want one of its corners. Okay, so you can have either if you tilt this side, you can have corner C in HP. But because we have lifted up this side up, we got the corner F in the horizontal plane. So this is the front view. Draw projectors from all these points and draw horizontal lines from these points. The intersection points are marked here and join all the points by straight lines. So this is the final top view. So this is the final front view. This is the final top view. Okay, next. Let's take a circular lamina, a circle now. Its diameter is given. It is resting on a point of its circumference. On the circumference, you have number of points, right? We don't have any corners like in the case of a triangle or pentagon or hexagon. We have number of points on the circle circumference. On its one of the point is on the horizontal plane. It's a surface making 30 degrees angle with the HP. Let's show its projections. So here, first of all, because its surface is making angle with the HP, take the plane in the horizontal plane itself. Because we want something in the horizontal plane. Otherwise, you can take the plane parallel to HP. There is no problem. Now, its surface making 30 degrees angle with HP. Final top view appears like this. Okay. Now, let's see how to draw this. Take the reference line. Draw a circle of 50 mm diameter. Show the dimensioning. Okay. And coming to this circle, we don't have corners, the points on the surface, like in the case of a pentagon or a hexagon, we have corners. But here, we don't have any corner points, but we can divide this circle into 12 equal parts. Maximum, try to take maximum as many points as you can, because once you take the points nearer, number of points are taken, the points will be nearer, and joining a freehand curve with our freehand, it will be very easy and you get an excellent curve. So here, let's take divide this circle into 8 parts. Because of convenience only, I have taken 8, but generally try to take 12 points. So 8 parts are divided. Now the entire circle, name these points in one order, right? A, B, C, D like this, and complete the cycle in the anti-clockwise or clockwise direction. It's up to you. Draw projectors from all the points and mark the front view. It's a line on the horizontal plane from this here to here. This is the front view. When you see this from the front in this direction, F, G, H are kept in brackets. F, G, H only. All the other points are visible. When you are looking in this side, this A, B, C, D, E, up to E, all these points are visible. So this is the front view. Now we have to show the angle with the horizontal plane. So take this entire plane at a 30 degrees angle to the horizontal plane, right? Like this. This is a horizontal plane and it's taken at a 30 degrees angle. So the same length, whatever is here, appears here, but at a 30 degrees angle. Now, mark these points here on this. All the points are marked without any change. Now, to get the final front view, draw projectors from all these points and draw horizontal lines from these points. Get the intersection points here. All the intersection points A, B, C, D, E, F, G, H up to H. Mark the corresponding without, there is a possibility of committing mistake. So be careful. A dash here, projector, and a horizontal line at A. This is the intersection point here. So after getting all the intersection points, name them like this: A, B, C, D, E, F, G, H. Now this is a curved surface. So join all these points by a smooth freehand curve like this. You have to draw the curve only, smooth freehand curve. There is no instrument to draw these curves. So the final projection is over. This is the final front view. This is the final top view. Okay. Hope you had understood this topic very well. If you have any queries or any doubts, do comment, like, share, and subscribe. Thank you.